Okay guys, so in this video, we're going to be talking about VSEPR and molecular geometry. So what you'll need is you'll need your periodic table to be able to do the Lewis structure like we did last time. And I'm going to post this little chart right here if you want to print it out or look at it. That's what we're going to be referring to. It's front and back, it's 2 pages. And I'll show you how to use it in a little bit. It'll help you determine the molecular geometry. Okay, so we can use the Lewis structure of a molecule to predict the shape and the bond angle of certain molecules. We utilize something called VSEPR, which stands for the valence shell electron pair repulsion model. Okay, so what we're going to start off doing is doing our Lewis structures. Okay, so carbon, you have 1 carbon and it's in group 4. So you get 4 electrons there. Oxygen, you have 2 oxygens and it's in group 6. So you have 6 valence electrons, so 12. So you get 16 electrons, which means we're going to have 8 bonds total. Okay, so 16 divided by 2 gives you the 8. So your carbon is going to be your central atom. Carbon has to have 4 bonds. Remember what I said, oxygen is a lot of time going to be double bonded. So let's try that. And oxygen usually has 2 lone pairs. Let's see if that works. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 bonds. Our carbon has 4 valence electrons, so it's good. Our oxygen, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so that's our Lewis structure. Okay, so we're gonna go to our little chart thing. Okay, and we're gonna look at the central atom. Okay, so our carbon is gonna be our central atom. It has what we call 2 bonding domains. Okay, so we look at the bonding domains. Okay, so it has 2 bonding domains and 0 lone pairs. Okay, so the electron domain geometry or electron group shape, whatever you want to call it, is going to be linear. Okay, the molecular shape, because it has 2 bonds and 0 lone pairs, is linear. Okay, so it's going to make a 180-degree angle. So electron geometry, so we're going to do this for both of them, is linear. And molecular shape is linear. Okay, so we're going to go through a few different ones, and show you some different examples with this. Okay, so boron. We have 1 boron. Boron is in group 3. Fluorine. We have 3 fluorines, and fluorine's in group 7, okay? So we're gonna add down, so we should have 24 electrons and 12 bonds, or pairs of electrons, okay? So boron's gonna be your central atom. That, okay? Remember what I said, the halogens are usually gonna have 3 lone pairs of electrons, so we're gonna start there. And boron has to have 3 valence electrons, so it has 3 bonds. 1, 2, 3. Okay? So let's count our total bonds just to make sure we did the Lewis structure right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we did it right. Now, the electron geometry. And the molecular shape. Okay, so to boron, we have 3 bonding domains because we have 3 bonds, okay? And no lone pairs on the central atom. So we're gonna go to our little chart. So when we have 3 bonding domains, it's gonna be trigonal planar. And then if we go back to our molecular shape, 3 bonds and 0 lone pairs is going to be trigonal planar also. And out to the side, you can see what it's actually going to look like. Okay, I'm not going to draw it like that. I don't expect you to draw it like that. We just need to be able to use this to, identify the geometry. Okay, CH4 is methane. So C, I have one C. Carbon is in group 4, so it has 4 valence electrons. Hydrogen, I have 4 electrons, and it's in group 1. So it should have 8 bonds. 8 electrons. So 4 bonds. So carbon is going to be your central atom. We're going to have 4 hydrogens coming off of it. Hydrogen should have 1 bond. Carbon should have 4. So it's all good to go. Our electron geometry. And our molecular shape. Okay, so our electron geometry. So we have 4 bonding domains and 0 lone pairs. So if we have 4 bonding domains, it's going to be tetrahedral. And then our molecular shape is going to be tetrahedral. Okay? Okay, so we've done some pretty easy ones so far where they've been the same. So let's do one that's a little bit different. Okay? NH3. So nitrogen. You have 1 nitrogen. It's in group 5. So it has 5 electrons. Hydrogen. You got 3 and it's in group 1. So we add down 8 electrons. So we get 4 bonds. Okay, so nitrogen is going to be our central atom. We're going to put 3 hydrogens coming off of it. Now, we have to have 4 bonds, and nitrogen has to have 5 electrons. So it has 1, 2, 3. We put 1 lone pair. So if it's in this, if it's in this group right here, it usually has 1 lone pair, 2 lone pairs, 3 lone pairs. Don't forget that. Okay, so we go to our bonding geometry stuff. So let's do electron geometry. Let's do molecular shape. Okay, so your electron geometry so we have 4 bonding domains. 1, 2, 3, 4. Okay. Now, we have 3 bonds and 1 lone pair of electrons. So it's going to be a little bit different. So 4 bonding domains, your electron group shape is going to be tetrahedral. Okay, and then we have 3 bonds and 1 lone pair of electrons. So it's going to be trigonal pyramidal. Okay, so you can see how that's going to look, from the diagrams. And if you want to look up, 3-dimensional shapes on YouTube or whatever, be my guest. Okay, last one we're going to do is water, H2O. So hydrogen, you have 2, and it's in group 1. Oxygen, you have 1, it's a group 6. You get 8 electrons. We should have 4 bonds total. Now, water is going to look like this. Okay, so you have to have 6 electrons on oxygen, and so oxygen's in group 6, so it's usually going to have 2 lone pairs of electrons like that. So we're going to go to our electron geometry table thing. Okay, so we have 4 bonding domains. 1, 2, 3, 4. Okay, so it's going to be tetrahedral. Now, our molecular shape, we have 2 bonds and we have 2 lone pairs. So 2 bonds, 2 lone pairs, it's going to be bent. Okay. Okay. So that's going to be, you know, these shapes determine the bond angles and reactivity. So that's why it's important to know, you know, your bond angles and, you know, the general shape. But this is just something I want to go through mainly for UIL because they see this, and you'll see this in your college chemistry class if you take chemistry. So I'm just trying to get you prepared. Now, what I would do is I would work through these example problems, and then I would work through set 2 notes, the example problems, and then I would go through and try and do the problems, okay? So if you have any questions, feel free to reach out. Have a good night.